Hello everyone. In this video, we are going to continue discussing the concepts derived from class inheritance. This time focusing on virtual functions. Okay? In simple terms, a virtual function is a function that can be overridden by a derived class. It essentially strengthens the capability of inheritance. We know that a derived class can directly call public methods from its base class. For example, show salary and set salary. But when you want these methods to behave differently from the base versions, you might consider designing it as a virtual function. Okay? And virtual functions come in two types: pure virtual functions and regular virtual functions. A pure virtual function means the base class only declares the function but doesn't implement it. The implementation must be provided by the derived class. Okay? And pure virtual functions are often used as an interface between modules. When an engineer inherits from another module's class, they are required to design and implement these pure virtual functions. Okay? To write a virtual function, you start with the keyword virtual and followed by the function definition like you normally would. For example, let's design a showInfo function that prints a short message. Okay, here we created a function showInfo to indicate that this is a base class. We can override this function in all derived classes. Let's use the engineer class as an example. When overriding a virtual function, it is best to add the override keyword. Okay, this helps indicate that the function overrides a base class method, improving code readability. While it is not mandatory, it is a good habit to form. Okay, let's continue to finish it. Okay, here showInfo is overridden to print a difference message, differentiating it from the base class. Okay, let's call these functions from main function and see the result. Okay, you can see that although both objects call the same function, the output is different. This is the essence of virtual functions. As mentioned earlier, pure virtual functions only define the methods named in base class, and the implementation must be done by the derived class. For example, we can write it like this. Okay, here we set the virtual function to equals 0, making it a pure virtual function. The base class has no actual implementation, so if the derived class doesn't implement it, errors occur. For example, if we remove showInfo from engineer and back in main function, you will see a red squiggly line under both. Okay, meaning it fails to compile. Let's recover the function. Okay, once a class contains a pure virtual function, it becomes an abstract class, meaning you cannot directly instantiate it. The compiler warns you that employee is now abstract, and instantiated it will fail. Okay, Virtual functions are an extension of inheritance, enhancing its capabilities and allowing more flexible class design. In the next video, we will introduce downcasting, combining concepts from this and the previous video. We briefly mentioned it when discussing polymorphism, but next time we will dive deeper and show it in action. See you in the next video.